still have a picture of you. You wanted to be to enter into that guitar shoe contest, right?
Don't forget to put the fun in functions, especially the rational ones. They make sense. Okay, what's the parent rational function? I think Obed told us last time, so don't tell us again. Yep. We are going to deal with the transformations of that graph more specifically today. Okay. We could make it really difficult, but we're not gonna. So we're basically dealing with everything 1 over x, all the children. Okay. So hopefully they don't act like teenagers. That's when things get difficult. Right? Okay. Don't tell me to shush. I can give you an F.
Said do it.
No, I did.
Yeah, you did.
Mike did.
Okay.
Well, I did.
Oh gosh.
What is, so you know this, right? Did we talked about horizontal and vertical asymptotes? Yes?
Yes.
You've heard those words, I hope? I can't remember, so. Okay. This, okay, that right there, does this function ever cross that line?
No.
Okay, that's called a, that was a bad question. It can cross the line, but as x approaches infinity, y approaches what? As x approaches infinity, y goes to 0, right? That would be called a horizontal asymptote because of that reason. And only spell it with one S, please. Yeah, you're a little slow. Okay. The equation of that line is y equals 0, correct? It's at y equals 0. So that's the proper statement you'd want to make. Okay, there's a horizontal asymptote at y equals 0. What about that? It's called a vertical asymptote. At x equals 0. Okay. How, the question of the day is going to be, how do I determine that? Okay. Because horizontal asymptotes are determined by end behavior. Okay. The question is, how do I determine vertical asymptotes? Okay. How do you know to use x approaches 0? We're looking for an infinite discontinuity, which is at what? Dividing by, right? So when the denominator equals 0, we've talked about this, right? When the denominator equals 0, we have an infinite discontinuity. In this case, okay, that's where x equals 0 comes from. Okay. Well, that's not end behavior because it's not the end values. The end values are x and approaches infinity, negative infinity. But you could say, as x approaches, and this is above your pay grade, so don't worry about knowing it if you don't get it. As x approaches 0 from the right, from the positive direction, that'd be this way, right? Y goes to what? Infinity. See, x comes from 2, 0 from the right side, and then y goes to infinity. What would this statement be? From the left, from the negatives. Yeah. Okay, that's not what I'm going to hold you to, but that he asked questions. So this would be one way to determine a vertical asymptote too. Okay, you could show this a vertical asymptote with this information, but this is the easy way.
Is it possible for that function right there across the x-axis?
It does not. But I can build one, a child of that. We can build a child that does. Right? Okay. So, are we good with this?
Yes.
All right, moving on. All right, let's talk about another one. Child, right? Exact same function. We just translated it. Which direction?
To the right.
Right 3
And down, or up 2. Or up 3.
and up 2. These are really easy because they give you your horizontal and vertical asymptotes. And again, just follow the lines. Okay. What's our horizontal asymptote? Y equals 2. Notice that that matches, right? And our vertical, x equals 3. Notice that. It's right there. So it's just parent function reasoning in this case, right? So if you get a basic one that follows the same format that we've been studying, should be straightforward. And that's most of what you're going to see. Okay. I do want to show you one more that's a little bit more difficult. We're going to bring an x into the top. Okay. That's about it. Basically, let's see what the question's asked here. Determine the asymptotes for the graph is one question. Okay. Graph the rational function, you've already studied that. We could describe the transformations that take place. That's, again, just right 3 and up 2. You could, I could ask you to graph some really nasty ones, but I'm not going to. Okay, so that's basically what you're looking at. You might have to get the graph and write the function, but you could do that, right? Just shifting it. Okay, I'm moving on because everybody's like to quit talking. Okay, how about this one? A little bit more messy. Ooh. Let's use this one here. This one. Does that follow our parent function format? No, it doesn't. All right, so it's not as easy. But you can still identify the vertical asymptotes very easily here. Anybody? You missed. Two's the right number in the statement, but you're missing something. X equals 2. How do we know that so fast? Makes the denominator 0. Okay. It does not factor out either. Okay, I'll get to that next. But if the denominator is 0, it's a pretty good bet that you have a vertical asymptote. There's just one case you have to consider. Okay, good. Horizontal asymptotes, when it gets like that, get a little messier. Okay, there are a couple of methods. This is the easiest one. Consider the highest exponent of x. Okay. In the denominator and the numerator. So what's the highest exponent up here? No. X to the first, right? This is technically x0, right? So we're going to use this here. Okay. And what's the largest exponent on the bottom? This one, right? Simplify that. What do you get? 3. Our horizontal asymptote, y equals 3. It's not harder than that. Okay. So.
What would happen if there was like 3x squared?
On the top, I'm going to show you that next, actually. That's a good question. Do you remember this situation here? What if I gave you that, and I said, what are the vertical asymptotes? Are there any vertical asymptotes here? Okay. You look at the denominator and you say, well, 2 makes this 0, correct?
Yeah.
But what does 2 also do to the top? It makes it 0 as well. Do you remember me showing you this?
Oh, yeah.
Yeah. Okay, so there is no vertical asymptote because we can factor out that denominator. Okay, so because we can factor out the denominator. Okay. What discontinuity is that? Do we remember?
Jump. No.
There's only one more.
Point.
It's a point discontinuity. Okay. In fact, when you graph this, we'll just make it real quick here. It is a linear graph, and then we're at x equals 2, with a hole at x equals 2. Okay, so this is y equals 3x minus 1, and there's a hole at 2, 5.
Bless you.
Okay.
Thank you.
That's what happens. That's the one special case where your little denominator thing doesn't really work. Okay.
So what does it say, no what?
No. No, because you can factor out the denominator. Way ahead of you guys on there. I will stop.
find that point discontinuity, you plug in what the weight or the value that would make x on the bottom equal 0.
Say that again.
So to find the point discontinuity for something like that, you find the x value that makes the denominator 0.
Yeah. But if that value makes the top 0 as well,
Yeah.
that's when you only have a point discontinuity.
Well, yeah, but and that would be what makes the denominator. If that x value would make
If an x value makes the denominator and the numerator 0, point discontinuity.
at that x value.
If it only makes the denominator 0, like here, if you plug 2 in, you get 5. This is an infinite discontinuity with a horizontal asymptote
But how do
and
you-
a vertical asymptote.
How do you know that there's the whole at 2 and 5?
Because that's
Because I plugged 2 in here.
But it gives 0.
No,
three
in
times
this
2
in this factor, it just gives me 5. These are gone now.
Oh, okay, so you do it
So
after.
I plugged 2 in here and here, but it gives me 0. But this gives me 5. That's how I know that. You want to see a harder one?
absolutely.
Sure.
I don't even know if I put this in homework, to be honest. Or I can spare you, it doesn't matter to me.
Spare us.
I'll
Well,
just-
on the homework?
I don't think it is.
Can we make
I can check. Let me check. But I think we're good. When we do these types of things, we really study them with an eye on preparing you for AP Calculus. If there's something really difficult that we don't really worry about in AP Calc, we usually don't worry about it. And that's what I'm looking at there. So 1 through 5, 7 through 9. $25. Yep, you're off the hook. All right, I'm done.
Oh, all right.
So hope if you understand all that, you're money.
Ah, damn.
And again, pay attention to those reviews. That's where I get the test questions from, or the spiraling. Friday. Oh, that should say 52 through 56.
And is this due tomorrow?
Yep. Tomorrow we'll talk about, the test review is already posted if you want to study. We'll have a little activity tomorrow to practice into behavior and increasing and decreasing and all that good stuff that we've learned. So, okay. Let me know if you have any questions.
Well, the test is on Friday, right?
Yep.